Hey, John Gilroy here. Around 2010, the phrase technical debt entered the vocabulary of software developers. Today, a review of technical debt, code abstraction, and AI for federal technology leaders. Hit the music, Manny. Welcome to the Federal Tech Podcast, the podcast that connects you to federal technology leaders. My name is John Gilroy, and I will be your moderator. In the virtual studio today is world-famous Sonny Hashimi. He is the head of global public sector for a company called Unquirky, Unqork. Sonny, how are you?
John, it's so great to talk to you again. It's been a little while, and I'm not sure if world-famous is the right moniker, but
oh, it's world-famous.
I certainly, maybe for other things than technology, but it's always good to talk to you.
Well, I opened up with this silly quote from 2010. You were in high school back then, Sonny, let's face it. But 2010, I mean, we all know, we all studied, iterative software development and agile software development. And then 28, 29, all of a sudden this term pops up of technical debt. And I think a lot of software developers understand exactly what it is, but there may be some listeners. And if we're going to talk about technical debt today and AI, maybe we come to terms and define it for our audience and proceed from there. So you're sitting on a subway, someone turns to you and says, hey, world famous Sonny, what the heck is technical debt anyway?
Yeah, John, I think this is becoming the kind of the challenge of our decade now, right? So listen, over the last 15, 20 years, it's no doubt that more and more of our world has become digital, right? Even in our private lives, how we bank, how we order groceries, how we, interact with each other is now relying on technology. So now that technology needs to be continuously built, enhanced, maintained, and modified, but more importantly, secured. And so when you convert that into a conversation on enterprise technology, the technology that the government uses, more and more government processes are now relying on that technology to serve its citizens, to serve the mission. But in our government use cases, the government needs mission is unique. If you think of the work that the Department of Education does, the Department of Commerce does, or the Department of CBP does, they have unique mission requirements. In order to serve that mission requirement, you need to build these bespoke systems that kind of do a one-off thing. And historically, the way we've built these technologies and capabilities is that we start from scratch. We say, okay, what do we need to do? Here's a bunch of requirements. And we're going to build exactly to this specification. And now that it's built, first of all, it takes so long. It takes years, 18 months, 24 months to build a thing, because these technologies are like, you're building everything from scratch. It's almost like painting the Mona Lisa from scratch every single time. And so you're starting with a blank canvas and you're building this thing. And now that it's built, it's not just about, okay, now that it's in production, mission accomplished. There's a long tail of maintenance. Anybody who knows federal budgeting knows that about 80%, if not higher, of federal dollars goes towards something called O&M, operations and maintenance. What is that? Well, that means that there's many, because everything you're building is so unique and bespoke, only the people who built it know how to maintain it. They know how that code works. They know what their API spec is. They know what the database looks like. They know where the bodies are buried, what are the kind of rubber bands and bubble gum that's holding it all together. And so here comes a security patch. Here comes a new feature request. Here comes a new integration that needs to be done. Or here comes just the fact that we thought that the legislation was going to be this, but now it's that, and therefore the requirement has changed. In order to change in that system to stay relevant and continue to serve the mission, the amount of work that's required to keep it going is enormous. In fact, by some count, about 70% of the initial work that was required to build a thing is required to maintain the thing. So now think about it. Imagine you build a house. You spent, $300,000 building the house. But imagine just to keep the lights on and keep the walls from falling over, you had to spend $200,000 every year to keep that house operating. That would be an insane model to kind of, be okay with. But somehow we tolerate that model for federal IT. So that's what we call technical debt. As soon as you build something, now you've inherited a headache of keeping people around to keep it operating, keep it secure, keep it scaled, keep it working, keep it updated, versions, the patching, the remediation, the poems. And not only does it cost a lot of money, but imagine this money going out the door because it doesn't add any mission value. You're spending this money not for new capabilities that help the mission, but just to keep the lights on. And that's the core problem that we're trying to solve at Unquirky.
Wow. Yeah, in the early days, and you remember the early days, it was, we'll come up with a solution and we'll iterate. We'll come back and we'll iterate. And I think in some mysterious world 10, 15 years ago, that might have worked. And so, of course, we'll just change and move it. But what's happened is this has gotten to the point where it's 70%. is it maintenance or is it iteration? And so you can use one term or the other. But I think the noble goals that the Agile software developers had when they climbed up that mountain in 2001, it's getting distorted here in the last 24 years.
And like the aspiration is still true, right? The aspiration is still that, hey, the way we do Agile is that we deliver capability in the hands of end users, we get their feedback, we iterate and build again. And we continue to improve that capability until it continues to add more and more value. Every time we go and build something, it adds more mission value. That's the aspiration. In practice, what we see is that increasing amount of that effort goes towards just keeping the lights on. I was, not to name the system, but when I was a GSA commissioner at the Federal Acquisition Service, there was a system that we were managing that required 30 sprint teams just for operations and maintenance. 30 sprint teams is, each sprint team is about 4 people. So now we're talking about 30 times 4 individuals, engineers, database specialists, who are just maintaining the thing that we built. Because this thing was built over the last 10 to 12 years, so it's gotten so complicated. It's like all these internal kind of capabilities that talk to each other, multiple databases. And so it's hundreds of people to manage and operate and secure something that just runs every day. And so it became untenable to do new things and new capabilities because we couldn't even afford to keep the lights on. And this is something that, by the way, is not just like I've seen this across the agencies. Every agency we talk to in my new role, we see the same kind of story. We need to do this. This has to be done, but we have to, every year that passes, we have to spend more money just to keep the lights on. Not because of inflation, not because the rates are gone high, because it keeps getting more and more and more complicated, more and more complex. And so IT teams fret and are like stay up night hoping that their business users don't come back with new requirements, because as soon as they do, they have to now unpack the Pandora's box that they just packed, reshuffle the things inside, and then try to pack it back up again. And by the time they close it again, it turns out now it's 20% more expensive to operate. And so this has to stop. There's no infinite resource. There's no number of, agencies' budgets are not infinite. They're not growing anymore. So we have to find a new way to build enterprise capabilities that actually reduce the amount of effort that's required to maintain them. So once they go into production, once they go live, there's really no work more to do when it comes to maintaining, securing, updating, patching, and scaling those things.
No. Well, you defined the problem very nicely. And if you're listening to this and you go to unqork.com, you'll find all kinds of terminology like codeless architecture and code abstraction. So we got the problem defined. So how can code abstraction help our federal, how do they get them out of this mess?
Well, so the way we define Unquirky and what we're doing is we're building a capability that we call code abstraction. Essentially, the way we see this challenge is that the reason why this technical debt exists, the reason why. So first of all, what is coding? Why is coding required? Well, anytime you're building a bespoke capability, you're going to write code. Whether you're using a low-code platform or you're using just a full-stack development, you're going to write code. In fact, by a research that we've done, about 50%, 30 to 50% of a project that is built on a low-code platform typically requires bespoke coding in a proprietary language. So you can't get away from coding, right? And the challenge then becomes, how do you design it in a way that code doesn't become debt? Right. And so what we're doing at Unquirky is that we're abstracting code. We believe that coding is a necessary evil, that organizations don't wake up in the morning and say, we'd love to write some code today. They want to achieve a mission outcome. And whatever that mission outcome is, everything else is secondary to that. Do we write it in Python or Java? Do we use SQL Server in the back or MongoDB? Do we use this or that product for UX? Do we do React or Angular on the front end? All of those are secondary to the CBP's desire to serve and protect the border. All of those are secondary technology decisions that frankly are necessary evils. So what we do is we take all of that off the table. An organization defines the business problem they're trying to solve using data definitions and UI elements. Here's what the data needs to do in this application. It comes in over here. It does this calculation. Users interact with it this way, and then goes forward and does that. And here's what it looks like. Here's what it needs to look like. All they care about is what does it look like? What does it do? And we take care of the rest. How that translates into what programming language and which database schema, that's on us. And so not only does it significantly reduce the effort that an organization has to do, they don't have to now hire and maintain database schema and analysts to define the security and the API spec. We do all of that. All they have to focus is on what is our mission, what is the data coming in and out, and what does it look like in the end user's hands? We take care of everything. And now, once they go live, that's it. That application runs no matter which programming language is hot, no matter which database schema needs to be retired. We take care of all of that. And so by abstracting all of that complexity, just like cloud abstracted all the data center complexity, back in the day, people used to have to worry about, does this server hard drive going to fail tomorrow? And do I need to buy power supplies and keep it in the closet somewhere in case the server fails? Or what about my power distribution unit? Can it handle the load? But when we went to the cloud, all of that noise was abstracted. You don't have to worry about now whether my rack has, 2U factor or 4U factor. That's Amazon's problem. That's Microsoft's problem. That's Google's problem. You just need to worry about how much capacity do I need, how much compute do I need, how much storage do I need, and then let them worry about all the details. In a similar way to that, in the application space, what we're doing is we're abstracting away all the noise. So you can focus on their mission and what outcomes you're trying to drive.
If you're listening to this and you're walking your dog or, I don't know, driving your car somewhere, listening to it on the train, and you want to get more information, you can go to Sonny's website, unquirk.com. And I think there's a white paper there called Uncork for Government, powered by codeless architecture, and dive a little bit deeper into the whole codeless thing. And I dug into it this morning. I got up early and I started typing in search terms, and I went to YouTube and Google, and I came up with this quote, Sonny. Now, I come up with these quotes, and sometimes I got to scratch my head and go, man, maybe not. So here's the quote I came up with. Talked about codeless. I said, look, 75% of large enterprises will use at least 4 low-code development tools for IT app dev. Three-quarters of big companies are playing around with this. I mean, that seems like a big number to me, doesn't it?
Yeah. It's a big number, and like what it tells me is that the problem isn't solved historically, right?
for the federal government or commercial, no one's got the
commercial.
Answer.
Yeah, I mean, it's the same. We're seeing them in banking, we're seeing them in insurance companies, healthcare companies. What happens is the following. This is the way typically a large organization is. Like, the pressure is real. Their end users, whether they're customers, whether they're compliance people, whether they're internal or external users, the pressure that they're exerting on these IT shops is real. They want more. They want it now. They want it faster.
Yeah.
Because the mission doesn't stop, right? And so these IT shops are like, listen, we don't have the luxury of time and distance to be able to build everything in a bespoke way, right? We're not going to be able to paint a Mona Lisa every single time somebody comes up with a new business requirement. So we're going to invest in one of these platforms, right? And the platforms promise, in some cases, deliver this art of the possible around, hey, you can reuse things. You don't have to write code. You can just configure things very quickly. You can go to market faster. But it's like a Lego set, right? So you're buying a Lego set. Well, the problem is that when you try to build the Millennium Falcon with a Lego set, it turns out that it doesn't have all the Lego pieces you needed, right?
Yep.
So then you're like, well, I can't do this particular project with this Lego set. So I have to buy a different Lego set for this other project. So that's now you're from 1 to 2. Then you tried to build a payroll system in that second Lego set. And this one doesn't do calculations well. So I need a different platform that does that. Oh, I need to handle a lot of documents coming in and out. That's not what this thing does. So I need a fourth one. And so we see this all the time where like you start out with one and then you're like, well, this is limited in this way. Now I'm going to have to buy a second one. A third one is specialized for this kind of thing. And now you've got instead of like reducing your headaches and problems, now you got 4 times the headaches and problems. Now you got 4 times the things to secure, ATO. Now you need 4 times the number of people with 4 times the number of certifications and qualifications to manage these things. And each one of them platforms historically has required specialized coding and proprietary languages. So instead of solving for the coding problem, you now have double the headaches. You've got the platform to secure and manage, and then you're just writing code anyway. And so to us, this is the problem. To us, this is the problem that hasn't been solved. And this is a symptom of a problem that needs to be solved, but hasn't been. And so this is what we're building a product to solve for. We believe that Unquirk in the future could be the one layer that every organization needs and all applications run in Unquirk because it's open source, it's cloud agnostic, and it can work in any environment. And you can build any application of any complexity on top of it. So we're seeing that in early stages in financial services. We have insurance companies that have actually basically migrated all of their business applications, your underwriting systems, your claim management, your employee onboarding, everything to Unquirk. And now they're building on that as a common platform. So we're excited about what we're building. Obviously, as a company, we have to eat our own dog food. So actually, one of the things that we're doing is everything that we build as a product for our own company, we build on our own platform. So actually, this is the only time in the world where if you actually use Unquirk as a designer to write applications, all of the products you're using are actually built on Unquirk so that we know that our technology works, it's secure, it scales, and all those kind of things. So we're excited about the opportunities. Now, the reason why I'm excited is like, listen, I'm a government guy. Most of my career has been in government, right? The reason why this excites me is that the mission doesn't sleep. The American people need services today. They need capabilities now. The agents at the border need services now. The people who are applying for student aid, that system needs to work. And so to be able to deliver a mission faster, which is what all federal CIOs are and state local CIOs are feeling the pressure to do right now, you have to do a different thing. The way that you've been trying to do this for the last 15 to 20 years is just not scaling. And you know this. It's becoming more and more expensive. It's becoming harder and harder to develop and scale. I was talking to a federal CIO just the other day, and they were telling me that not including license costs, they're spending over $20 million a year maintaining the applications that they have built in low-code platforms. $20 million is no joke. You know, a global company like Spotify takes about $40-50 million a year to operate.
Yeah.
So now you're telling me that one agency needs about half of that money just to maintain applications that they built? That's not okay. So like a new way is needed. We are confident that we're building that. I'm sure other companies feel the same way, but a new conversation is required. And to me, AI is a central component of that new conversation. So we can talk about that too.
Well, that leading right into AI. I wrote down proprietary, and then I wrote down open source, and it seems like the combination of open source and AI might be a solution to this log jam. It's what it is. I mean, it's a log jam and not making any progress if you're maintaining it. So where does AI fit in this talk?
Yeah, it's a great question. So before I tell you about how we're thinking about this problem and how we're solving it, there's a risk here. So I'm hearing a lot of interest and a lot of excitement in the AI space, generative AI especially, among our customers and clients and large enterprise CIOs is that, hey, one of the ways to solve this problem that we've identified is we can just ask AI to write the code, right?
Yep.
It's too expensive to hire developers, it takes too long. Why don't we just ask AI to write us Java code, .NET code, or whatever? I think that's a huge mistake because generative AI is very powerful and it can write code. So if you gave it some specifications and a prompt or two, it can write you a Java library or .NET code or whatever, but it doesn't solve the technical debt problem. In fact, it makes it worse. So now you're writing code faster. You're writing more code faster that still needs to be maintained. So here comes 2 years from now, and all of a sudden there's a security vulnerability in the log4j library, or there's a security vulnerability in a particular Java version. And you're going to ask your team to go and update this application to the new Java version. Well, this team doesn't even write the code. How are they going to understand it and then update it? And so using generative AI carelessly, you can actually make the problem so much worse because now you're writing more code that frankly you didn't write. A human trust factor is not in the loop. So you don't know if this code is secure because it's basically borrowing other code libraries from other people that have written it. So you don't know if those vulnerabilities are getting, through AI, the vulnerability that the engine was trained on code that may have vulnerabilities inherently that now you inherited. And you still have to maintain and update and patch and manage. Yeah. So the way we think about it is that by abstracting code, you can solve this problem. Because Unquirk is basically an open specification for what a business application needs to do, rather than code libraries, you can ask AI to build an open specification for what the business needs to do. So as an example, you can tell OpenAI to say, listen, I need a form entry application that automates this form. It goes through a workflow that touches these people. And it needs to have this condition that needs to check for this before other things get done. Go. And it can convert this human set of specifications, user stories essentially, into the open specification that Unquirk understands. We then take that and apply that code to it. So we take that security hit, we take that compliance hit. And so we've actually shown this to people where you can literally take an old mainframe application and convert it in real time using generative AI to Unquirk. Literally takes 3 minutes. In fact, if you're around and if you're available on September the 6th, we're actually hosting a hackathon at the Carasoft headquarters in Reston, where we're encouraging people to bring your own legacy. Bring an application, a Java application, a .NET application, a whatever application that you feel is a little long in the tooth. And in an hour, we're going to convert that using AI to an Unquirk application. And once it's an Unquirk specification, you never have to worry about managing it again. And so the beauty, the future of AI is to not convert and create new code. It's to convert it into an open specification that any product can then understand, including Unquirk. And that's why you get out of technical debt, you get out of vendor lock-in, and you still use AI to accelerate that process.
Yeah, it's during this conversation, you have used words like bespoke and words like proprietary. And And that may have been fine. Your father's Oldsmobile, I mean, your father's software, but and the funding's not there anymore to be able to tolerate that type of administrative costs. So it's great. I'll put the links to the document I mentioned earlier in the show notes page. And September 6th, if I'm in town, I'll run down to Caresoft and see what's going on. It could be fun just to see what you come up with. It'll probably shock some people how fast it can come up with that code. It's interesting, Sonny.
We've actually seen people convert mainframe applications that were 2-year projects into a modern cloud-based open standards-based application in less than 20 minutes. Oh. That's the level of acceleration we're talking about. So listen, of course, I work for the company. Everything I say should be taken with a grain of salt. But all I say is, listen, I'm not a salesperson. Give us a big, hairy, audacious challenge, and let's prove it to you. If you can't prove it, no harm, no foul. We'll learn from it and we'll do better. But there's proof here that is really game-changing. And I think AI, for the first time, is poised to accelerate digital transformation, not just by a factor of 5 or 10, but a factor of 100 or 1,000. And that ultimately the risk is when you convert your legacy into something, let's make sure that something is not new kind of technical debt. That something is actually going to be open, it's going to be manageable, it's going to be long-term sustainable, and it's going to be vendor agnostic. That's the right kind of strategy with using AI to get out of legacy.
Great. Well, unfortunately, Sonny, we're running out of time here. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Sonny Hashimi, Head of Global Public Sector at Unquirky.
John, thank you so much.